Without question, my most watched video to date is this one.
And he's got a gate. Well, don't know about you, but I'm convinced. I'm off for a pint.
Well, guess what? Not only is Chris UK back, but he's back with another gate. And this time, he's serious. Hello all and welcome to another episode of Flat Earth Friday with me, Simon Dan. Thank you very much for joining me. Yes, Chris UK is back with more scientific experiments to wipe the grin off of our faces. His choice of gate this time round is much more rural and he has way more apparatus. Let's see what he's got. He's got some northern English countryside. He's got a drone. He's got some string and a ball. And he's got a gate. What is he doing? Well, this all looks very high-tech, doesn't it? Let's hope it goes a lot better than the last one. Well, he didn't do very well disproving it last time, did he? Yay! There it is! More on that in a trilogy video. The field of view. Okay, this should be interesting.
So if you're looking at an item through a set field of view and you're close, it fills the field of view. But as you move back from the field of view, it shrinks in that field of view.
Well, if that's your experiment, I hate to break it to you, buddy, but it's kind of been done. Like, a lot of times.
Proving that it's close. Because if it was 96 million miles away, it wouldn't do that. The same with the stars. They should be the same in both fields of view. And if they shrink in the fields of view as we move away or across, then they're a lot closer than we're told. We can work out with this how far the stars are, how far the sun is, and how far the moon is. We've just got to work together using practical science, trigonometry, to get to know the truth.
Practical science and trigonometry, hey? Okay, sounds easy. Let's begin then.
But as the sun moves across, the fields of view from each field of view changes. as it's closer to one than the other as it moves across. So this happens with the sun, the moon and the stars. But the sun, because it's 93 million miles away, shouldn't do this. And the stars, because they're trillions of miles away, shouldn't do this. So if the sun's closer, this is what we'll see.
I'm sorry, I'm not really sure what your point is. Are you saying that the sun gets smaller and bigger in our field of view as it moves across the sky? Because if you are, that's not the case.
If the sun's far away, we should see it's the same out of both fields of view, but we don't. The same with the stars. The moon, not so much, because we think it's close anyway. So you can see the fields of view changing as the distance varies between each point.
Yeah, I'm going to need more of an explanation here, mate.
So looking out of my window in my room to the sky, we can see through a set field of view. And I wondered to myself, what would someone else see through that same window at another place on the planet if we live on a ball and stars are trillions of miles away? Or we're on a flat plane and the stars are a lot closer, the sun's a lot closer, and the moon's a lot closer. And I think I've worked it out.
Oh, he's worked it out. Chris UK has done what no flat earther can do. Come on then, Chris, lay it on me.
Just by looking through a set field of view. So you've got two fields of view, thousands of miles apart or hundreds of miles apart. Would they see the same thing if they're different distances from, say, the sun, the moon, stars?
Well, as long as there was no atmospherics in the way, then there'll be no difference in angular size at all. That's because the difference in the distances between 2 points on a globe compared to the distance to the sun is so minuscule it's not even worth mentioning.
And you should, if the stars are trillions of miles away, see the same thing. But if with that distance you see a different thing through these set fields of view, then they're closer. And we can work out with trigonometry how far they are.
Interesting that a flat earther wants to use mathematics. Normally that's a little bit of an Achilles heel.
So you've got two people, say 500 miles apart, there, and 500 miles to there, both lined up to look at the same point. 300 miles away, 600 miles away, 3,000 miles away. At these 2 points are 1,000 mile difference. From that point, you'd see something different at each field of view.
Well, if we're talking about the sun, it would be in a slightly different place in the sky, but there certainly wouldn't be any size difference. The stars, though, again will be in a slightly different position because of your position on the globe. Different latitudes and longitudes, of course. And there'll be no difference between individual stars either, and certainly no size difference.
If the stars are 1 trillion miles away, you'll see the same in both fields of view. But you don't. You see a difference in the set fields of view. So this is not angular view, it's set in a field of view at 2 points, looking at the difference. And if the stars are 1 trillion miles away, you shouldn't see any difference. If the sun's 96 million miles away, you should see hardly any difference.
But if you're on a different longitude or latitude to someone else on a globe, then the sun will be in a slightly different position. And that's because you are on a globe. Are you really proving the globe right now?
If the moon's 125,000 miles away, you should see some difference. But we can, using this method, we can track the moon across the sky, the sun across the sky, and the stars across the sky, and work out for ourselves how far these things are. If they're close, if they're far. If they're trillions of miles away, we don't see any difference from the two fields of view. If they're close, we do. That's the point I'm making.
Yes, I get your point, but I think your hypothesis is wrong. Two different positions on the globe will see two slightly different skies. And that has nothing to do with how far away these things are, it's got everything to do with your position on the globe. I mean, if one of you is in the northern hemisphere and the other one in the southern hemisphere, then your skies will look completely different.
This is massive proof that stars, the sun, are close. The moon's a little bit harder to work out because we know it's closer, but we'll get there. We work together, we'll get there. I'll work out how to set this so everyone can set out a field of view to use as a reference. So everyone can shoot the stars wherever they are. The same star should be the same for everybody. But if in the set field of view it's different for everybody around the globe, or the ball, or the earth, or wherever you think you live, then they're lying to us. Set field of view. That's what I'm on about. Not angular view, angular movement. Two set fields of view, two 1.5 metre windows at 1,000 miles apart, looking at a distant object 600 miles away, will see a different field of view through each point. Because it's close. So if the stars are close, they'll do exactly the same thing.
Okay then, you're talking about a set field of view. Well, if you're looking at the same object from different positions on the globe, there will be no difference. Actually, I tell a lie. If the two of you are on different hemispheres, then the moon will look reversed. I think we need to see some diagrams. Luckily, Chris UK has a whiteboard. Maybe he stole it off Conspiracy Cats.
So we've got the globe, we've got space, and we've got a flat plane. The stars close. So if we're in space, we've got two spaceships 1,000 miles apart looking at the stars. So they're 1,000 miles apart, the stars are trillions of miles away. Both fields of view in the spaceship will see the same thing. We'll see the same stars, the same size, fill in the window, the field of view the same.
Right, okay, happy with that?
Here's our little man looking out at his field of view at one station and the other. We'll see the same thing through both viewpoints, both fields of view. So if a spaceship comes along to this one here, there's a spaceship, it will fill the field of view there, but on the guy looking through his field of view 1,000 miles away, it will just be a dot, or even nothing 1,000 miles away.
Okay, with you so far.
So this is in space. We should see them stars the same at both points. So we move this to the globe. So we've got 2 points here, and the stars here. If the stars are trillions of miles away, we should see the same. Yes, obviously the atmosphere around Earth will affect what you see, but the furthest point is the one going through the most atmosphere, so possibly the furthest point you're looking at will be more magnified looking at the stars in the sky.
He really, really doesn't have a clue, does he?
So what I'm saying is, if you're in space, both fields of view see the same thing. If you transfer the two spaceships to Earth, it's still 1,000 miles apart, looking at the same stars, both fields of view will be the same. But slightly different due to atmospheric length, possibly.
And that is exactly true. That is what we see.
Now, if we move on to a flat plane, where we're saying the stars are a lot closer, we've got 1,000 mile distance, the same as there, and the stars are over here. So, if they're close, the field of view from each point will be different, as we've shown you. So, the closest will be there. Further away will be smaller.
This is me patiently waiting for an example of this. You will never find an example of this, ever. And why is that? Because the stars are so far away.
And this can be the sun, the moon, or the stars. And as we track it across if they're close, so if the stars are closer, as stars get to there, they're an equal distance from each field of view. So this field, the two fields of view will be the same. And as the stars track it across the sky, or the moon, or the sun, the field of view, if the stars are closer, the moon's closer, and the sun's closer, will change gradually as the distance from there and there to the stars changes. So this set field of view, don't forget we're setting the field of view, will change as the stars move, the moon moves, or the sun moves.
I'll tell you what, you find me a video where at the start of the night a set of stars are close together, then slowly space out and get bigger in your field of view, and then get smaller and come close together again.
Now we can use trigonometry to work quite a few things out on this. So if we're seeing a change in field of view, we know the stars, the sun and the moon are close.
Except it doesn't change, but I'll humour you. Trust me, it's worth it.
So here's our two fields of view, looking through the same window, the same reference. 1,000 miles. Okay, so the stars we say are 1,000 miles in the sky, or 1,200. So as we're tracking stars across the sky, using trigonometry we can work out how high the stars are. So when both fields of view are the same, in both points, that one, then we know that the middle point here, the stars are directly above us. Obviously with atmospheric differences, that can change. So if that's 45 degrees, that's 45 degrees, and that's 45 degrees.
Whoa, 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 whoa. What was that?
So if that's 45 degrees, that's 45 degrees, and that's 45 degrees.
Chris, buddy, come on. The sum of the interior angles of a triangle always add up to 180 degrees every single time, not 135 degrees. I kid you not, this is 11-year-old maths.
It's an equilateral triangle. With trigonometry, you can work it out. So if that's 30 degrees, you can work out that angle and use trigonometry to work that out.
I'd bet that he couldn't use trigonometry to work that out because he just waved his hand and said, oh, you can use trigonometry to work that out, without actually showing us an example. So what we have here is, and this is by no means an insult, I am merely stating facts. What we have here is a man who doesn't understand basic maths, who is trying to educate us on the distances to stars without even showing us any examples or images. I think we can safely say that we no longer need to watch any more of this, and we could announce that he is talking utter nonsense. Let's leave Chris to his gates. Right, that wraps up another episode of Flat Earth Friday. Thank you very much for joining me. If you liked it, then please do like and subscribe, and even tap the bell for notifications as well if the feeling takes you. I have been Simon Dan. Have yourselves a great weekend, and I'll see you all on Sunday for a Memory Lane special. Until then.